All right. We are ready for, we're on page 4. Not page 4, problem 4. D. 4D. On practice test number 1. So, the question says, we need to multiply D times A. Well, let's remember what the rule is for multiplication matrices. What are the dimensions of matrix D? 2 by 3. What are the dimensions of matrix A? So we have a 2 by 3 and a 3 by 3, and they are multipliable because the rule for multiplication matrices is these two have to match. And they do. So here we go. Our answer will be another 2 by 3. So 2 rows, 3 columns. These match. This tells me how big my answer is. So I'm going to multiply row 1 by column 1. That's this spot right here. Row 1, column 1. So here we go. Row 1. And then I match it up with column 1. And then I multiply each pair and add them up. So what do I get? -2, -1, and 0. -3. And then I move on over to next spot, which is still row 1, but now it's column 2. So I write down my row 1 again, and I'll match it up with my column 2. -4 and 1 and 12. 9. Lots of arithmetic. You'll have a calculator to help you. You need it. And then what's this? This is still row 1, but now column 3. So row 1, column 3. So -6 and 0 and 4. -2. Now what do we get to do?
To the bottom.
Same thing, only we're going to use row 2 now. Row 2 and column 1, 2, 3. All right, so go ahead and do that. You do that. See if you can get that bottom row. You're doing row 2. I want you to check my anybody have a question about one of those numbers? We're all good? All right, next, what are we doing in problem E? Finding the inverse. Go. This is easy, but there's kind of a process. Anybody remember the process? How do we find the inverse? First, we find the determinant. All right, so first thing we do is find our determinant for inverse B. So that will be 1 times 3 minus 2 times negative 1. This is like what you do when you do Kramer's rule. 3 minus negative 2, so I got 5. You get 5? All right. Then, you may remember what you do next? We make a new matrix. Random new matrix. And how do we make that new matrix? What's the rule there? These two numbers switch. And these guys, their signs change. So he becomes negative and he becomes positive. So we make this new matrix. Then what? One more step.
Put it over 5.
All of these get put over that number right there, 5. If it reduces, we're going to reduce it, but I don't think anything here reduces. So it's just 3/5, 1/5, negative 2/5, 1/5. And that's your inverse. So remember, if your fractions reduce, you have to reduce them. All right, easy enough. Now we got another multiplication. A times C. What do you think about A times C? Not doable because the dimensions of A are 3 by 3 and the dimensions of C are 2 by 2. And these have to match and they don't, so therefore that problem is not doable. There are some problems that you cannot do.
For D, if it was A times D, would we not be able to do it then?
A times D.
Instead of D times A?
Well, what are the dimensions of A? 3 by 3. And D is 2, yeah, no, not multipliable. AD wouldn't be multipliable, but DA is.
Yeah.
All right, so we already, yesterday we did a page of substitution, elimination, Kramer's rule. Now we just finished the page of matrix operations, addition, multiplication, inverses, all that. All right, what's next? Now we have a big determinant. This is problem 5. We have a big determinant. What do we do here? How do we solve this?
Copy the first two rows.
First 2 columns, exactly. Copy them just as they are, stay organized. Right? Now, start multiplying. So negative 15, negative 4, and 0. And total them all up. It looks like that one is negative 19. So again, lots of arithmetic. Multiply, 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 add them up. Then what? You're not done. Do the other way. So here, that's going to be 6. That's going to be 10. And that's going to be 0. So that's 16. Then what do we do? What do we do with those 2 numbers? We don't add them. Subtract them. That's a subtraction. So your answer is going to be negative 19 minus 16. So the answer is negative 35. Okay. All right, next. Oh, now we have vocabulary. What are the dimensions of that matrix right there? 2 by 4. 2 rows, 4 columns. 2 by 4. If this is matrix A, what is A sub 2, 1? 5. That means the entry that is in row 2, column 1, and that is 5. In the expression 2A, where A is a matrix, 2 is called a scalar. S-C-A-L-A-R. Scalar. It's called a scalar. What's your test look like? This, there'll be vocabulary. What is a square matrix? Same number of rows as columns. Same number of rows as columns. That's how you get to the square, right? Length and width are the same. Rows and columns are the same. Define matrix, here it is. I told you on day 1, this would be a test question. A rectangular array of numbers arranged in rows and columns. Okay, if that's in your notes, make sure you know it. I'm not going to keep saying it. It's in your notes. Learn it. What do we mean by an entry or an element? An entry or an element, what is that?
Number.
Those are the numbers inside the matrix. They're referred to as entries or elements. Either way. All right, now we got our word problem. All right, so let's see what we can get filled in here for our word problem. Oh, this one's got a little bit of a different thing in it. Let's talk about that for a second. All right, so we have hamburgers, we have hot dogs, total number, fixed interval. That's something we haven't had before, but it's easy. It's in a lot of these problems. It's easy. Let's see what we got. A snack bar cooks and sells. To stay in business, it must sell at least 10 hamburgers, but not more than 40. That's what we call a fixed interval. What does that tell me about my hamburgers? They have to be somewhere between 10 and 40. So the way we write that is for our hamburgers, if we'll let X be the hamburgers, then X is going to be between 10 and 40. An interval. 10 and 40. Another way of writing that would be with your brackets, if you wanted to write it that way. That tells you that however many hamburgers you sell, it has to be between 10 and 40. Now, that is super simple to graph. I'll show you in a minute, but let's fill in the rest of the table. It must also sell at least 30 hot dogs, but not more than 70. So for hot dogs, we're between 30 and 70. And again, if you prefer to write that like this, that is A-okay. That is your interval notation. You cannot cook more than 90 sandwiches altogether. So in other words, your total number of sandwiches has to be 90 or less. So your total number is 90. Profit on a hamburger is 33 cents. Hot dog is 21 cents. I'm gonna let X be the number of hamburgers and Y be the number of hot dogs. What do you think about that? All right. Now, remember, if there are pieces of the chart not filled in, that's okay. What is your job? Every number goes in the chart. Once you have all the numbers in the chart, whatever it is, okay? So I'm not worried at all. All right. Now, what am I going to graph? What am I going to graph? Well, what does that top one say? X plus Y is less than or equal to 90? Now think about that, you guys. Doesn't the problem say that I can't cook more than 90 sandwiches? So whatever hamburgers and hot dogs I make, together, they have to be less than 90. I'm also going to graph my fixed intervals. This is what makes them so easy. You just graph them. And I'll show you how it's so easy. And then, of course, X and Y have to be positive because you can't have negative hamburgers. Is this a max problem or a min problem? And what am I trying to maximize? Profit. And how am I going to calculate my profit? 0.33x plus 0.21y. All right. Now, looking at these numbers, I think I want to use the scale of 10 again. Count by tens. So if I cover up X, Y is 90. And if I cover up Y, X is 90. Shaded in the side, the triangle there. All right. Now let's graph this one. Now pay attention. This is really easy. I know we haven't done it before, but it's super simple.
Cookie?
Huh?
Cookie?
Are you kidding me? I got a million cookies over here on the shelf. These are free. But thank you.
Yep.
All right. Now this only has one letter in it. See that? And the letter is X. So I come down to my X-axis. I'm going to put a dot at 10. And I'm going to put a dot at 40. And then I'm going to draw a line straight up from both of those. Where do you think I'm going to shade? I've got these two pink lines. Where do you think I'm going to shade? In between them. Absolutely. Where's that X? In between them. So I got my line at 10. I got my line at 40. I'm going to shade in between them. So right now, so far, can you see that we are under the blue line and between the pink lines? So we're really looking at this space right here so far. But now I gotta throw one more in there. Now I gotta do this one. Any idea how I'm gonna do that one? I'm gonna go up on the Y-axis now. And I'm gonna put a dot at 30. A dot at 70. Draw lines through those dots. And where do you think I'll shade that purple? In between? I'm shading in between my purple dots. Okay, now guys, we're in between purple, we're in between pink, and we're under blue. Do you see something that looks like this? Now you are shading, I can't shade my board, just becomes a disaster. But hopefully you're seeing that your purple, pink, and blue overlap is right here. Now, some of these points are super easy. For example, see this guy right here? What point is he?
47.
X is 10 and Y is 70. Isn't that the point 10 comma 70 right here? And what about this one? This is point 10 comma 30. Those horizontal and vertical lines make it really easy. What's this one? X is 40 and Y is 30. Now, believe it or not, this one right here is also easy because he is on this pink line. This point is where pink and blue are crossing. This pink line, all of the X's are 40. Look, all the X's are 40. But on the blue line, they have to add up to 90. So if X is 40, Y is 50. So that's another one. And then can you use the same logic here? Look, what do we know about everything on this purple line right here? Y is 70. Y is 70. So whatever this is, the Y is 70. But it's also on the blue line, which has to add up to 90. Now, what are we trying to figure out? How to make the most money, right? So what do we do to figure that out? We take each of these X's and Y's and we plug them in here, right? So put 10 in for X, put 70 in for Y, and figure out how much money we make. And then move on to the next point and so on. trying to make the most money, right? So when I look at these two ordered pairs, with this one, I'm making 10 hamburgers and 70 hot dogs. With this one, I'm making 10 hamburgers but only 30 hot dogs. Does it seem logical that maybe that one's gonna be more than this one? So I could have crossed that one off at the beginning because I know that making 70 is gonna be better than making 30. You don't have to do this, but you can. Then let's look here. This one's 40-30, and this one's 40-50. Wait a minute, I'm trying to make the most money, right? So is it 40-50 gonna be more than 40-30? So I could cross that one off. Now, this one's 10-70, and that one's 20-70. Won't that one be more than this one? So from the beginning, you could have narrowed it down and not typed in all of them, but it's okay to type in all of them if that's what you want to do. But sometimes you can rule them out.
The test, will there, like, for the graphic part, will there already be, like, the numbers, or are we gonna have to, like, add on more numbers to that?
You might have to add on more numbers to the graph. That's okay, you can do it. All right, one more page. Our calculator problem now. And some of you are simply not listening to me when I tell you that to get full credit for this problem, whether it was your quiz, your homework, or now the test, you have to write down the matrix that goes in, the matrix that comes out, the button that you pressed to make it all happen, which is RREF, reduced to echelon form. And then you write down your answer as an ordered pair, ordered triple, or whatever. All right, so what do we got? Looks like we have P's, Q's, R's, and S's. So 1, -2, 3, -5, and -34. Does that look okay to everybody? Now what about row 2? We got 2 P's, 1 Q, uh-oh, no R's, -4 S's equals -16. Now we have no P's, 1 Q, -1 R, -1 S, equal to 1. No P's, 2 Q's, 3 R's, no S's, and -5. What happens if you put in the wrong matrix? You will get the wrong answer. So make sure that you are lining everything up and getting the zeros in the right spots. How big? How big is this guy? 4 by 5. Yep. Little bigger than usual. But it doesn't matter. It's not actually work. 1, 2, -3, and 4. How's that look to everybody? That's what I got. Now, that one was rigged. Obviously, I planned that. If I didn't plan, then my answers could come out being very messy, right? So what do we do if they come out very messy? We press math frac, right? And that'll change them into fractions for us, and then we can write down our nice little fractions. Okay, if you want credit, more credit for this problem, that's what has to be written down. Is everybody straight with that? No complaining, just to write this down. All right, practice test 1 in the books. Let's go to practice test 2 now. All right, I want you to take a minute, you and your partner. And I want you to do this first page. I want you to do substitution, elimination, Kramer's rule, and I want you to check your own work, right, with each other. And then we're gonna talk about what the answers are. So everybody's engaged, everybody's working. Make sure you're doing the right way. We're doing substitution first. Okay, Nolan's gonna put number 1 up here. Move out of the way. Let's see if somebody else can put. Ready to done with all of them? Anybody else done with all of them? Anybody else put one of the others on the board for us? Which one you done? Elimination, all right, last is gonna put elimination up for us. How many of you got 1,3 for the first answer? Good. Now remember, when I check this, because the directions are specific, the directions are very specific, I will be checking for something like this right here. Nolan decided to get y by itself, great choice. So we ended up with negative 2x plus 5, or you might have said 5 minus 2x. It doesn't matter, they're both fine. Get y by itself, and then he plugged it right back in right here. And he did all of the arithmetic. Yep, nicely done. Does anyone have a question about that? All right, let's take a look. Last volunteer, thank you, to do problem elimination number 2. So it looks like he chose to multiply his second row by -3. Now, again, that's beautiful. What we need to do is make sure that we multiply everything by -3. So he did. Perfect. Then he added these and that eliminated. So we ended up with 17x equal to -34. So he divided by 17. Uh-oh. What's -34 divided by 17? -2. So then he went back and plugged that in here. So 2 times -2 plus 3y equals -4. So -4 plus 3y equals -4. Wait a minute, what happens when I add 4 to both sides? I get y equals 0, that is exactly right. Y is 0. Okay? Is all right with everybody? Anybody have a question about that? How many got that one right? Okay. Shoot, like to have everybody. All right, the last one, Kramer's rule. Anybody want to come up with Kramer's rule on the board for us? Okay, yeah. watch Kyle and see if they match. Have you done it? Yeah. Then do it, Ronnie, right now. We're on the wrong page. No, you're not gonna have a reference on test data and then anything. So the first thing Kyle is doing is writing down his determinant of his coefficients. So the x's and the y's. And he's getting negative 13, it looks like. Perfect. Now he's gonna build two more determinants. This is what I will be checking for. How do you get these two new determinants? Take out the x numbers and plug in 7 and 1. And then take out the y numbers and plug in 7 and 1. So we erase both of those negatives then, because we don't ever want, when you end up with negative over negative, those are gonna cancel. So 36/13 negative 17/13, that looks absolutely beautiful. Tomorrow we'll get our quizzes back, but that's what you did on yesterday's quiz, one of the things you did. Anybody have a question about that? Everybody okay? All right, here we go. Page 2. Or, yeah, the next page of our practice test. This is our matrix operations page. So we're gonna do all kinds of stuff. Why are you talking? Okay, let's not. Let's focus on math. Your dial. All right, here's matrix A. The question says, find the inverse. We already practiced this today. It's a process. What's the first thing you're gonna wanna do? Find the determinant, which is exactly what Kyle just did up here. When you do Kramer's rule, that's called determinant. So it's negative 4 minus 6. So negative 4, we do this one first. Negative 4 minus 6. Everybody okay with that negative 10? Now hang on to it for a minute. Because what's the next thing we have to do? We have to make a new matrix by switching these guys and making these both negative. Remember, if these are positive, they become negative. If they're negative, they become positive. All right? That isn't the answer though. What do I need to do now? All of these have to go over my negative 10. And then when I fill in the answer blank, I reduce everything. So here, the negatives cancel, and 2's cancel, so that's 2/5. This one is this one is 3/10, and this is -1.
It's not negative?
What?
Are they negative? Oh, I didn't see them. Okay.
This one's negative. For all the rest of them, the negatives cancel,
Alright.
okay? Anytime you have negative over negative, they're gone. Okay? B, problem B, 2C. Okay, if you miss this one, I'm not sure what to tell you. 2C, what do we need to do? Multiply everything in C by 2. It's like a distributive. So it'll be 246, -228. Bless you. And that's all there is to it. Okay, so what did I do? I took everything in the matrix and multiplied it by the number. It may not be 2 next time, it might be 3 or something. You just multiply by that number. Okay? What's the word for this number right here? What do we call him? He's a scalar. Yeah, that's a scalar. All right. A times C. Before I write it all down, A times C, can I do it? What are the dimensions of A? 2 by 2. And the dimensions of C, oh, I can do it, right? I can do it. So here's A. Here's C. And I got my 2 by 2 and my 2 by 3. So when I multiply them, what am I going to end up with? What am I going to end up with here, guys? 2 by 3, so 2 rows, 3 columns. Remember when you multiply, it's easy, but there's a process. It's row times column. Row times column. Tear Green, you awake back there? Uh-oh. Think we got a snoozer. There he is. Put that head up, Terry Green. Head up. Sit up. Feeling okay? Good. All right, here we go. Row 1, column 1. So row 1, my row 1 numbers, match them up with my column 1 numbers. I got -1. All right, and then I'll go to maybe row 1, column 2. Row 1, column 2. All right, go ahead. You do it, I'll do it, we'll compare answers. This is really easy to mess up, so let me know if you don't agree with one of my numbers, because it's definitely possible that I messed up. class says he matches. What about the rest of you? You good? So everybody feels comfortable with multiplication. All right, problem D. Addition. A plus B. Can't do it. What's the rule for addition?
They gotta be the same
Gotta be
dimension.
the same dimensions, that's right. So problem D is a no solution. Can't do it. How about E?
No solution.
B times D. That's another no solution because B is a 3 by 3 and D is a 2 by 2 and these don't match. So nope, not gonna happen. All right, last one. Can we do 2D minus A? I think we can. So 2D. 2D would be negative 4, 2, 6, and 12. Everybody okay with that? 2 times D. And then I'm gonna subtract A. This is so easy, guys, but be careful with your arithmetic. Negative 4 minus 1. Negative 1. 2 minus 2. 6 minus 3. 12 minus negative 4. And there's your answer. I did that kind of fast. Anybody have an issue with that, any of that? This is 2 times E. And then I'm subtracting negative. All right. We will pick up there.